In the last video, we talked about the laws of exponentials. And so in this video, what we're going to do is we're going to work on simplifying exponential expressions. Alright, so let's begin with a problem. We have been given the instructions to simplify the following expression, and here's our expression. So we have the quantity 5x cubed, x to the negative third, all over 10x to the negative second, all raised to the third power. Okay, so we want to think, how do we want to start simplifying this thing, and what order is there to follow? Well, in general, we should try and follow the order of operations. So just as a reminder, we have the order of operations acronym PEMDAS. Okay, so we want to first work inside parentheses, and then many of the times all we have to do is do exponential expressions next, because then multiplication and division we don't necessarily have in a lot of these problems. But let's go ahead and get started. So we're going to work inside the parentheses first, so take care of that stuff. Now if I do this, so I have something to the third power, that doesn't change. So inside here I have a 5 x to the negative third, or x to the third, x to the negative third, all over that. So let's take this one step at a time. Let's just look at the numerator. Is there anything that I can simplify with in the numerator? Well, the 5 stays the same, okay? But now when I come to the x's, I have those two there. And they're both in the numerator, so if I just look at the numerator, all I have to do is add the exponents, because we have exponential expressions of the same base, so I add their exponents. So it's going to be an x to the 0, and then the rest stays the same as well, over 10x to the minus 2. Okay, now another simplification you can make is remember that the zero exponent rule. So this is actually, if you want to write it as 1, you could. Okay, so that's all the same. Next step. Okay, now there isn't any real more or any other simplification that I can really do in the numerator, so what I'm going to do is look at the numerator and denominator together. Okay, so I have a 5 and I have a 10. Let me leave the third out here. So the 5 and the 10, what simplification can I make in between those? Well, I know a 5 and 10 reduce, they both have 5 in them, so this is really a 1 and a 2. Okay, and then that's all the further that I can simplify that, and now I look at the x's. Okay, these are both exponential expressions. What do? Well, it's a quotient, because I have x to the 0 divided by x to the minus 2, so I have to subtract the exponents. So I do a 0 minus a minus 2. So I'll put this in the, and you'd put the result in the numerator. So it'd be x to the 0 minus a minus 2. Okay, and if I work that out, or just rewrite it, so this is all to the third power. That's a x in the numerator. I can get rid of the 1 because it's just multiplication. And so 0 minus minus 2, that's x to the positive 2. Okay, and this is all over 2. Can I simplify this further? No. So what I'm going to do is now use the quotient, what was it? The quotient, the power rule for a quotient rule, and distribute the 3. So this is going to be equal to x squared to the third power all over 2 to the third power. And when I do that, power to a power rule says I have x to the 6th multiplying the exponents, or the powers, and then 2 to the third is 8. And that is the end of that problem. Okay. Now, in general, with these exponential expressions, you could have distributed the exponent first. I will warn you that it does get a little bit messy if you do that, but it'll work out to be the same answer should your algebra all be correct. Okay. In general, though, I would recommend first, if you have parentheses, work inside those and simplify it before distributing that exponent. Alright, so let's go on to another problem. Fairly similar, but what do we notice? We have three variables. We have x, y, and we have z. Okay, so this one's going to be a little bit more intense, but same process, nevertheless. Okay, so I still have whatever cubed. I'm just going to leave that alone. And now I'm just going to look at the numerator and denominator separately. Okay, so in the numerator, what can be simplified? Well, I have the x's again, so I'm going to write this as 7, and this time I'm just going to write it as 1 instead of writing out x to the 0, but just know that, maybe I'll put it in red, is that this is really x to the 0 power, and then I have y to the 5th, z to the -2nd. Okay, no other simplifications I can make in the numerator. Denominator alone, 42, all that good stuff, that can't be simplified either. Okay, so now what do I do next? I need to look between the numerator and denominator. Alright, so I still have the cube out here. I have division. Okay, now I'm first going to look at the 7 and 42. Well, what happens when I do that? Well, that becomes a 1 and a 6. Okay, and I have multiplication. Right, and now I'm going to look at the y's. So I need to do a y, and now I have a y in the numerator and denominator, so I have to do 5 minus a -7. Okay, and then also down in the z's I have a numerator and denominator, so I have a z, and I'll have a -2 minus 3. Alright, so then when I simplify this, still have the cube out here, I have 6 in the denominator, 1 I can drop. I'll have a y to the 12th, okay, z to the, this is -2 minus 3, so that's z to the -5. And so I don't want negative exponents typically, so what you need to do is write that in positive exponents. So remember, if it's negative in the in the numerator, it's positive in the denominator. So that means I can move it down to the denominator as, let's see, I'll have y to the 12th, and then it'll be z to the 5th, and I have 6, and typically we write the 6 in front to the 3rd. Okay, almost done. Now this is as simplified in here as we can get, so what I'm going to do is distribute the 3 to all terms. And when I do that, I'm going to have y to the 12th to the 3rd power all over. I'll have 6 to the 3rd power times z to the 5th to the 3rd power. And so I'll end up with y to the 36th power over, I'll leave it as 6 cubed for now, and then z to the 15 because I multiply the powers. And that's as simplified as I can get. Okay, so this problem, there were some more variables involved. Doesn't make it necessarily harder, just a little bit more to do. And so what we did is we simplified first in the numerator and in the denominator. We looked at those separately. Then what we did was we looked between the numerator and denominator and simplified that way. And that was this entire process. And then lastly, after we got it as simplified as we could, we distributed that exponent and got this result as at the very end. Now keep in mind, as I mentioned, you could distribute the 3 first and simplify from there. The numbers get higher and a little bit messier, but the algebra will work out to be the same in the end. Okay, so that's a couple examples on simplifying exponential expressions.